So, good morning, students. Let me hope you're all fine, and let me hope the semester is treating you guys well. So, in the previous video, we were looking at how to solve differential equations using the method of separation of variables. So I'm very sure you've done enough exercises, and I hope you understood whatever I looked at in that lecture. Excuse me. Okay, now in today's video, I want us to look at what we call first order exact equations. At the moment, at least you know what a first order differential equation is. But the new term which I'm seeing in this case is the word exact. So what exactly does it mean? So no worries, you're going to understand what it means. Okay, so we have that any first order differential equation dy dx equaling to f of xy can be expressed in the form capital M of xy dx. This capital M of xy denotes just any function with two variables x and y dx plus another function with two variables x and y, we are calling it n dy equaling to 0. So this is the fact that if you have a first order differential equation which is in this form, you have dy dx equaling to something or equaling to any function in two variables x and y, you can always maneuver around and you can always simplify that differential equation into this form. Let's look at some examples. So our first example is this. We have dy dx equaling to 3x squared minus y over x minus 1. So we want to express this differential equation in this form. Let's see how we can do that. Okay, so where is the pen? It is here. Which one did I use? Maybe this. I use that. Okay. Is that so? What is this one? Highlight. Pen. Okay, I use that. So we have, let me write here. We have dy over dx equaling to, forgive my handwriting, equaling to 3x squared minus y over x minus 1. So the first step is going to be cross multiplication. When you cross multiply, you're going to have x minus 1 brackets dy equaling to 3x squared minus y in brackets dx. Okay, dx. So this is just cross multiplication. Then let's take this 3x squared minus y dx, let it cross the equal signs so that it goes to the left hand side. So what shall we get in that case? We shall end up with x minus 1 dy minus, since it is positive this side, when it crosses the equal signs, it will become a negative. So minus into brackets 3 x squared minus y dx. Okay, but let's try to compare with our formula. Our formula starts with dx, then it ends with something dy. So let's start with this. So if we start with this, that means we shall have minus into brackets 3 x squared minus y dx plus x minus 1 dy. Oh, so when we crossed this one, this side, this was supposed to be equal to 0. Oh my god, I had forgotten. So this is equal to 0. But now we don't want to deal with the negative. Let's make this negative enter the brackets. When the negative enters the brackets, that means negative times negative y will be positive. So we shall end up with y minus 3x squared dx plus this time x minus y dy equaling to 0. Okay, so let's compare this with our original equation. That means when you compare this equation to ours, that means that m of xy is y minus 3x squared. That's why we have something like this here, and n of xy will be equal to x minus 1. So this was the first order differential equation, and we've been able to manipulate it so that we get this form. Okay, now let's look at another interesting property. So let me first erase this. Erase. Okay, and I stop the pen. Okay, now in the second example, we have an equation x dy plus y dx equaling to 0. So when you look at this expression, it is in the form m of xy dx plus n of xy dy equaling to 0. Okay, so what I'm trying to say is that this expression here is in this form. M of xy dx plus n of xy dy. What is m and what is n? Now I want you to get this week that m goes with the x, n goes with the y equaling to 0. Okay, so that means for this expression, n goes with the y. That means n of xy is x and m of xy is y. Okay, so that means this equation is this form. But now I want you to observe. Supposing now we are going back to your A-level mathematics. You're given a function p. Oh, where is the pen? So you have a function p equaling to x, y, and you want to differentiate this function, okay, with respect to x, for example. So that means that dp dx will be equal to, now since this is a product, that means you are going to use product rule. How does the product rule work? You first have the x, then dy dx. I will not go into details of product rule, dy dx, plus y, then dx, right? Dx. Okay. Yeah, so what I wanted to show you is that when you look at this left hand side, you have x dy dx plus y dx. Okay, taking you back a little bit, using the product rule here, we say that you have u, this is u, and this is v. So the product rule states that maybe dy dx is the same as u dv dx plus v du dx dy.